Hey guys, Miss Hamilton here. Just going to be talking about word problems day 3, looking at percents and mixtures. So this is a little bit more challenging than the other day problems. So I'm going to show you a table method in order to really help you. So for example, Sean invested $8,000, part at 9% annum and the remainder at 4% annum. And after 1 year, the total interest was $420. So what we're kind of looking at here, okay, is the percent. So we're going to say let X represent the 9%, and we'll say let Y represent the 4%. Okay? And so what we're going to look at is actually drawing those out. So we have 9%, okay, and 4%. So we're going to do a table, okay? And we're going to start first with the amount, okay? So the amount, so we said that X plus Y totaled $8,000, okay? Now let's just look at the interest rate, okay? So we are going to change, we're going to convert 9% into a decimal, which is 0.09, and we're going to change 4% to decimal, which is 0.04, just by dividing by 100, right? And then now what we can associate those interest rates with, okay, is a variable. So now we're going to look at the total interest that was accumulated. So we're saying 0.09% of the amount plus 0.04 of the other amount added together totaled $420 of interest. So what you've done here is you've actually created two equations, okay, and I'm going to highlight those for you. So you created one equation here, which is X plus Y equals 8,000. And you've created another equation here, which is 0.09x plus 0.04y equals 420. So now with those equations is an option of choosing substitution or elimination, okay? How I would go about it is I would probably choose substitution because I know I could rearrange this first equation. So I'm just going to rearrange. Okay, rearrange, just writing that out. So I get Y equals 8,000 minus X. So what I'm going to do is in that equation, I'm going to replace the Y here. Okay. So I'm just going to move it over just so I can write it nicely here. So we have 0.09X plus 0.04y, which I'm going to replace with 8,000 minus X, okay, equals 420. So the first step here is to make that table, okay? Second step, identify the equations. Third step is to really solve, okay? So let's solve this, okay? So 0.9x. Now we do distributive property. So we get 0.04 times 8,000, which gives us positive 320. And then 0.04 times x, which is negative 0.04x, equals 420. So now it's about rearranging. So I'm going to move 320 to the other side. So I get 0.09x minus 0.04x equals 420. Subtract 320. So here I'm left with 0.05x is equal to 100. And now what we can do is we can divide the 0.05 out. And we're left with x equals 6,400. And that would be dollars because we're working with money. Okay. So we found what x is equal to. Now what we can do is step 4, okay, is we're going to take the first equation, which we rearranged. So just going over here, I'm going to take this equation. So y equals 8,000 minus x. And I'm going to find what y is by just substituting in that x value. Okay? So we found that y equals 8,000 minus 6,400. So we find out that y equals $1,600. So $1,600, okay, dollars. So what we've been able to do in this question is solve, okay, for two unknowns, okay, based off linear systems here. So you have found out, and you can just check this, okay, that y equals, okay, 1,600, x equals 6,400. Just think about the math there too. Do they add up to 8,000? Yes, they add up to 8,000. If you were to plot them in, you could self-check as well by using the equation. Can you check if that works? Okay. So I would say the percentage questions with money are easier than when we get into mixture questions because there's one extra step. So let's do one more example of this. Okay. So a student decides to invest $1,000 into a mutual fund. She invested some at 24% annum and the rest at 12% annum. She made $210 on her investment after 1 year. How much was invested at 24%? So they're just asking us to find 24%. So what we can do is when you're looking for your variables, let's talk about that. So let's let x, okay, represent 24%. Okay, so let x represent 24%. Okay, and let y represent 12%. So again, all we have to solve for in this case is x because they just want to know what the 24% is. So when you're going about this, we're going to kind of think in that retrospect how to solve for just x. So let's start with the table again. Okay, so doing the table. Okay, we're going to start with 24%, okay, and 12%. Okay. So we start with the amount, okay. So we're saying x plus y gave us a total of, okay, $1,000. And now if you want to kind of skip that extra step here, you could just do the interest totally, okay. So if you kind of know what the interest rate is now, you can kind of just go right to the interest. So you could say that 0.24x, okay, plus 0.12y gave you a value of $210. Okay. So again, you have now created two equations. You've created x plus y equals 1,000, and you have created 0.24x plus 0.12y equals 210. Now, they're asking us to solve for x, okay? So in order to solve for x, you want to make sure you're eliminating out the y variable when we go to solve this, okay? So what I would do is I would rearrange this equation here. So it's y equals 1,000, okay, minus x. Because when you plug it into the other equation, then you're left solving for x. And that's what we want in the end, so you don't have to do that other step. Okay. So now, let's sub this equation into our y. Okay. And I'm just going to move over to do that. Okay. So we're going to go 0.24x, okay, plus 0.12. Now again, we're replacing that y with 1,000 minus x equals 210. And we can go about this. So again, we start with distributive property. Okay, so 12.12 times 1,000 is going to give you 120. And then we're going to be left with negative 0.12x equals 210. So move all the terms to like sides. So I'm going to keep 0.24x plus or minus, sorry, minus 0.12x, and then I'm going to move 120 to the other side, which becomes negative 120. Becomes negative 120. Okay. So now we collect those like terms. We get 0.12x equals 90. Okay. Trying to isolate for x here, so we divide both sides by 0.12. We'll find out that x equals 750. Okay, and that would be dollars. So again, all I asked in this question was to solve for one of the variables, so I don't have to do the other step because I'm just asking what does 24% equal in this situation, and I identified x representing 24% as my variable. Okay. So those are just two examples of how to use the table with percentages with money. Now I'm going to show you how to use the table with percentages with mixtures, which involves one extra step. Okay, so we're going to move on over to these questions. Okay, so mixtures. Okay, maybe put a little star here. Okay, because this is going to get a little bit different when we start using the table. Okay, so I'm just going to zoom in here. Two concentrations. Okay, at 50 and 100%. She wants to produce 300 milliliters of an 80% solution by volume of how many liters of each solution should be used. Okay. So again, the idea is to use a table, okay? And we're going to say let x represent the 50%, and we'll say let y represent the 100%. So we start with the table, okay? So we're going to go 50 here, and we're going to go 100% here, okay? And we're going to start with the amount. So again, how much liters do they want in the end? That's what we're kind of looking at here, okay? So what we're saying is x plus y, okay, is going to equal the amount of 300 milliliters, because that's what they want in the end, okay? But next what we're going to look at is we're going to look at the percentages, okay? So we're going to look at the percentage. So they want 0.5x plus y, because 100 divided by 100 is 1, so if you want to put 1 to help you out, that's fine, okay? Is equivalent to, okay, 300 milliliters, but at 0.8% because they want 80%. So this is where I'm getting that value from. So the one extra step is occurring right here. So you have to actually take 300 and times it by 0.8, which you get a value of 240. Okay. So right here is that extra step I was kind of talking about, where you're looking at what do you want in the end it to produce in that solution. So what you have now is you have two equations. You have x plus y equals 300, okay? And then you also have this equation now, okay, of 0.5x plus y equals 240. And now you have a second equation of 0.5x plus y equals 240, okay? So what we're going to do is you can use substitution or elimination, again, in the situation. But right now, when I see it, I could easily do this as elimination just to give you guys another method of showing you how to do this. So I just stack up the equations. X plus y equals 300. 0.5x plus y equals 240. Okay. So then what I would do is I would choose an operation. I'm going to choose to use subtraction because that would eliminate my y's in this situation. Okay. So then when we go about it, we get x minus 0.5x, which is just going to leave us with 0.5x, okay, is equal to 300 minus 240, which is 60. Okay. And then I would divide both sides out by 0.5. And I find out that x equals 120. Okay. And this would be milliliters in this situation because that's what we answered for. Okay. But you're not quite done because this question asks for both components, right? And we found what it was at the 50%, right? So that's milliliters at 50%. Now, just to solve for y, all I would do is I would take my other equation, okay, so and x plus y, okay, equals 300, and I plug in my x value, which I found, which was 120. And now I would just isolate for y. So 300 minus 120, okay, gives you 160. So then we found out that y equals 160 milliliters, okay, and that's at the percentage of 100%. Okay. So how you go about it is really still the same as other questions. The only thing you have to remember in mixture questions is that extra step as I highlighted in the blue. And so we're going to do another example just to help you out there, okay? So moving on down over here. Okay. And I'm just going to erase the other data that's in our way. Okay. So a chemistry teacher needs to make 10 liters of a 42% sulfuric acid solution. Okay. So that's what they want in the end, 42% at 10 liters. Okay. The acid solution available is 30 and 50%. So how many liters of each solution must they mix? Okay. So again, we're going to start with just identifying our variables. So let's say let x represent 30%, okay, and let y represent 50%, okay? And we're going to start with the table, okay? Again, if you don't want to use the table method, you don't have to. For some people, it will work well, it won't work well. It just depends. So let's start with 30%, 50%. So just identifying what we're working with. And we go with the amount. Okay? So we know that x plus y, in the end, we need to have 10 liters. Okay? But now we have to look at their proportions. Okay? So what we're going to do is, I'm just going to show you even a longer version of how it works, okay, is we know the percentage, okay, is 0.3 and 0.5 here. What you could do if you wanted to, because this helps, and we know that in the end we want 0.42, okay, percent, you can multiply straight across to solve, okay. So that gives us 0.3x, multiply here, 0.5y, okay, and then 10 times 0.42, okay, which gives us 4.2, okay, and this is where we found the percent per, okay. So that's just another way to kind of look at this chart if you want to. So you've created two equations. You've created an equation here, and you've created an equation here. So if I wrote them out, we know that x plus y equals the 10 liters, but we also know that the percentage part, so 0.3% plus 0.5y, is going to give us 4.2. So again, it's going to be your choice to use substitution or elimination. In this situation, I probably would use substitution because I can quickly rearrange that first formula. So I would go y equals 10 minus x. And then now I can sub this value, okay, into my y of that equation, which is what I'm going to do now and show you. So I'm just going to move over on the slide. So we get 0.3x plus 0.5, substitute in the value of y, which is 10 minus x, okay, is equal to 4.2. And now I'm going to go about solving that. Okay? So we get 0.3x, use distributive property to multiply in. Okay? So we get plus 5, okay, minus 0.5x is equal to 4.2. Collect the like terms, so we're going to get 0.3x, subtract 0.5x equals 4.2, subtract 5. Negative 0.2x is left here, but negative 0.5 is left on the others. Negative 8 is left on the other side. Divide by negative 0.2, negative 0.2. Okay. And we find out that x is 0.8 divided by 0.2 is 4. And that would represent liters. So x is equal to 4 liters in this situation, which we said that x in this situation, okay, represents 30%. Okay, so 30% of sulfuric acid at 4 liters. Now what we're going to do is we're going to find out what we solve for at the other percentage. So I would take your rearranged equation. So I would take y equals 10 minus x. And now because you know what x is, you're going to sub that in. So y equals 10 subtract 4, and we get y equals 6 liters. And that 6 liters was at 50%. So again, guys, for mixtures, you have to do that one extra step of multiplying the final result by the final percentage of the solution you want. So your homework for today, okay, is outlined page 9, 4, 6 to 8, 11 to 16. Please feel free to message me at any time in regards to these questions. I am available today by email, so I can even answer those and send them back to you if you're having an issue, or send me a picture of what you're doing. I can find errors in that for you. Okay, and have a great day.